Usually constitutes of statistics and kinematics. Question 7 is statistics. So let's look at question 7 right here. Looking at question 7, it says a survey is carried out in a town and it revealed that 25% of the household surveyed owned a laptop and 70% owned a desktop. In addition, it was found that 12% owned both a laptop and a desktop. If a sample of the household from the town is selected at random, determine the proportion that neither owned a laptop nor a desktop. All right. Now this question, you can answer it numerous amount of ways. You can use a Venn diagram. You can use anything you want. Let's say you wanted to use a Venn diagram. All right. This is just, I'm showing you how maths is connected. All right. The universal set just represents 100%. All right. Universal set in this case represents 100%. All right. I told us that you have a certain amount that own laptop computer I'll use for L, and they said a certain amount use desktop computer, and desktop computer I will use as D. So this is desktop computer. They told us how much own laptop. 25% own laptop. So if 25% own laptop, all right, and how much own the both? 12% own both. All right, so this is 12. So if this is 12, then in here where it's laptop only is 13, because we need 13 plus 12 to give us the 25. Then out here now is what? Right here, so now is 70% on desktop computers, but 70 minus 12 is 58. So desktop only is 58. So here what this question asks us now. It said, if a sample of household from the town is selected, determine the proportion that neither owned a laptop or a desktop. So out here, I'm going to call X. Now, what I know is that from my Venn diagram, 13 plus my 12 plus my 58 plus my X is equal to 100%. All right, that's what I know from my Venn diagram. All right, now 58 and 12 is 70 plus 13. 70 plus 13, let me check that with my calculator. I'm not as sharp as one time. That's 83. All of this is 83. And so 83 plus X is equal to 100%. And so what does that tell me? That tells me that 17% is X. All right, that tells me 17% is X. So this is telling me that 17% neither owns a desktop or a laptop computer. That's what that is telling me. So this is using a Venn diagram. I'm just getting creative to do this question. Nice and easy. That's part A. Part B says a bag contains 4 red marbles, 3 black. A bag contains 4 red marbles, 3 black marbles, and 3 blue marbles. 3 marbles are drawn at random without replacement. Find the probability that all drawn are the same color. So find the probability that once you draw you draw the same color. Now, in order to draw the same color, there are three ways this can happen, all right? So the probability of you drawing the same color means we're finding the probability that you draw red, then you draw red, then you draw red, plus the probability that you can draw black, then you draw black, then you draw black. All right, that's still drawing the same color, plus the probability of you can draw blue, then blue, then blue. So if I let black, B represent black, for blue, I'm gonna write BL. BL represents blue. You can draw blue, then blue, then blue. So let's work this out now. So this is going to be equal to the to draw red on the first one is going to be, you have 10 marbles. How much red did it? 4 red. So there's a 4 out of 10 chance the first one going to be red. Times, when you take out 1 red, you're left back with 9 marble, and then 3 red in there. So the next red will be 3 out of 9. Times, when you take out that red now, you're going to be left back with 8 marbles. But how many red will be in there now? 2. So that's the probability of getting red, red, red. Plus the probability of getting black, black, black. You have 10 marbles and you take out a black. The chance is 3 out of 10 to get a black. Now after you take out that black, you're going to have 9 marbles left. And so if you take out another black marble, there's 2 more in there, so it's 2 out of 9. When you take out that black, there's going to be 8 marbles left, but only 1 in there that's black. So the chance of you getting the last black is 1 out of 8. Plus, it's going to be the same for the blue. 3 out of 10 times 2 out of 9 times 1 over 8. And this question is so easy. Soft with a capital. Let me say it again. Soft with a capital T. Too easy. So you work this out and you get 4 over 10 times 3 over 9 times 2 over 8. This is 1 over 30 plus, you can just work out everything in a calculator. 3 over 10 times 2 over 9 times 1 over 8. That's 1 over 120 plus 3 over 10, 3 over 10 times 2 over 9 times 1 over 8, and that's also 1 over 120. That's equal to, let's work this out now. So 1 over 120 plus 1 over 120 plus 1 over 30, and that's just 1 over 20. So that's the chance of you getting the same color. So there's a very slim chance. There's actually a 5% chance of you getting the same color. So I wouldn't even dream of picking the same color 3 times. Now it says, find the probability that the marbles, that when you draw the 3, it contains exactly 1 red marble. So to find the probability of getting just 1 red marble, it means it doesn't matter about the other 2 colors. So you can get, there are many solutions. We just want 1 red. So there are 2 ways you can do it. So to find the probability of getting exactly 1 red is equal to, let me write it down, the probability of getting 1 red, that's going to be equal to 1 minus the probability of no red. That's the only way you can get it. So the probability of 1 minus no red will give you the probability of 1 red. This is one way you can do it. So let's find the probability of no red first. All right. So the probability of no red, this is one way. I'm just showing you one way. Another way you can do it is the probability of 1 red, just showing you the both methods. The probability of 1 red means that we can say it is the probability of getting, to get 1 red means you can get maybe a black and a black and then a red, all right? Or you can get the probability of a black and a blue. Let me use L for blue, black, then a blue, then the red. It doesn't matter, it's just 1 red there, plus the probability of getting a black, or the probability of getting a blue, and then a red, plus the probability of getting, you can get, so blue, blue, black, black, and there's a chance of you getting a blue, then a black, then a red. That would be the probability of getting 1 red. All right, that's the probability of getting 1 red. You just want to know, say you get at least 1 red. All right. So anyway, you want to work it out, which is 1 minus the probability of no red, or you can work it out as probability of 1 red is this. So let's do it both ways. All right, I'm going to start with the second one since it seems shorter. For the second one, which is the probability of 1 red, the second method is just the probability of, so the probability of 1 red. In this case, I'm just going to write 1R is equal to the probability of getting a black, then a black, then a red is 3 out of 10. Then when you take out that black, you get now times you have 2 black left out of 9 times the red now is, you have 8 marbles in there and you have to take out 1 red. 1 red will be, let me see, 1 red, 4 red in there, so it's 4 out of 8 plus, and you do the same for these and these and these and these. All right, this method seems longer, but this is the principle. I'm just going to do the first one. 1 minus no red. It does seem shorter now. So the probability of no red means you draw absolutely no red at all. To draw no red at all, you can either draw black, then black, then black, or you can maybe draw black, then blue, then black, or you can draw black, then black, then blue, or you can draw black, then black, then black, or you can draw blue, then black, then blue, then black, or you can draw black, then black, then blue, or you can draw black, then blue, then blue, or you can draw blue, then black, then black. Let me see if I got all them. With the 3 blacks, yes. Then with 2 blacks, you can either draw black, black, blue, black, black, blue, and then you can draw blue, black, then blue, blue, then you can draw blue, then black, black, then you can draw blue, then black, then blue, or you can draw blue, 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 or you can draw Let me see. Or I can draw blue, black. Let me see. This match black, 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 blue, 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 black, 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 blue, blue, black, black, blue. We need blue, black, black, blue, black, 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 blue, black, blue, black, or black, blue, black, or blue, black, blue. Feels like one's missing. Is one missing? These are all where the possibilities with no red. We can draw black, 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 blue, blue, blue. We can draw black, blue, black, 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 blue, blue, black, blue, 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 black, black, blue, black, blue, and blue, blue, blue. So look at the two cases where we can draw straight blue or straight black. Or look at the possibilities and we can be drawing two blacks, that's these two. Look at the possibilities, we can be drawing two blacks. Look at the possibilities, we can be drawing two blue. Two blacks can be black, black, blue, blue, or blue, black, black. Yeah, here's another one. All right. So those are the three possibilities we can draw. Two black. We need the three possibilities so we can draw two blue now. So what are the three of them? We have can draw the black first, then blue, blue. Or we can draw the blue, then the black, then the blue. Or we can draw blue, blue, black. That's the one that is missing, blue, blue, black. Blue, blue, black. A new one was missing. So this would be no red. So let's work it out. So the probability of drawing black, black, black. We worked it out up here already. The probability of drawing black, 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 which was 1 over 120. Then the probability of drawing black, then blue, then black will be black, then blue, then black. It's 1 over, not 1. How many black is there? 3. So it's 3 over 10 times, drawing your blue now, you're going to have 3 over 9 times, drawing your next black now is, we take out one black already, so it's 2 over 8. Plus, drawing blue, then blue, drawing black, then blue is going to be 3 over 10, 2 over 9, then your blue is 3 over 8. And notice something. Notice that this and this is the same. Plus, draw blue, then draw black, then blue is 3 over 10 times, drawing blue now is 3 over 9 times, drawing the next blue is 2 over 8. All right. Without working out the rest, I can see where this is going. I can tell you that blue, black, black is going to be the same. 3 over 10 times 2 over 9 times 3 over 9. I can see it times 3 over 8. I can tell you already. Plus, this again is going to be 3 over 10 times 3 over 9 times 2 over 8. Plus, of course, your blue, 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 which you know is 1 over 120. Plus our blue, blue, black, which again is 3 over 10, 2 over 9, 3 over 8. We're going to work out all of this. That will give us the probability of getting no red. All right, so when I work it out, it's going to be 3 over 10 times 3 over 9 times 2 over 8. That is 1 over 140. This right here is 1 over 40. And look how many 1 over 40 we have. 1, 2, 3, 4, 5 of them. Is it 5? 1, 2, 3, 4, 5, 6 of them. So this just works out to be 1 over 120 plus 1 over 120 plus 6 over 40. 1 over 120 times 2 plus 6 over 40. And I'm getting 1 over 6. So that's the probability of getting no red, 1 over 6. So what does that mean? That means we're very likely to get a red. So the probability of 1 red, is equal to 1 minus 1 over 6. And the chances of you getting a red is 5 over 6. So there's a very high possibility you will get a red. Very high possibility. There's a very high chance you'll get a red. So that's it. Probability of 1 red is 5 over 6. Nice and easy, soft. Now let's go to part C. Part C says the probability of hiring a taxi from garage A, B, or C is a half, 0.5, and 0.2. The probability that the taxi ordered will be late is 7%, and from B, 10%, and C is 20%. Use a tree diagram. Nice and easy. Tree diagrams are so easy. So first and foremost, recognize that you have 3 taxis. So that's where you start it with. You start with your 3 taxi then. So I just use this dot as a reference point. You have A, you have B, you have C. So taxi A, taxi B, taxi C. Chance of you using taxi A is 0.3. Chance of you using taxi B is 0.5. Chance of you using taxi C is, I think that's a 0.2. And then now it says it gives us the chance of each of them being late. All right, so I'm going to use black to extend the other line. It's either taxi A or show up on time. What can I use for on time? We can use L for late, and on time mean T, arriving on time. All right, T means on time. So it says the chances of A being late is 0.07. There's a 7% chance A will be late. So there's a 93% chance A will be early. I would want to go with taxi A. Taxi B, there's a 10% chance taxi B will be late. I don't like that service. All right, so on time and late, you're telling me that there's a 10% chance taxi B will be late, and this one is 0.9% chance it will be early. Then let's go way over to here with taxi C. Now, chance of taxi C being late will be 0.2. That's 20% chance taxi C is being late. That is very high. That's a very high chance. I wouldn't want to go with taxi C at all. This is a tree diagram. This is part CI. So we're done with tree diagram. Nice and easy. Let's hear what them have to say now. So they said now a garage is chosen at random. Determine the probability that the taxi will be late. So what's the chances of the taxi being late? So the chance of the taxi being late will be the chances of A being late plus the probability of B being late plus the probability of C being late. All right, so the probability of a taxi being late, I'm just going to write the probability of the taxi being late is going to be equal to chances of A being late. So the probability of A being late is going to be 0.3 times 0.7. 0.3 times 0.7, because that's the chance of A even getting picked, plus the probability of B actually being late, because B, there's a 50% chance B will come and a 10% chance B will be late. So the probability of B definitely being late is 0.5 times 0.1 plus, now C, now probability of C getting picked is 0.2, and then chances of C being late is 0.2. So I multiply those. That will give me the chance of this taxi being late. So the probability of the taxi being late will be 0.3 times 0.7 plus 0.5 times 0.1 plus 0.2 times 0.2. That's 0.3. So that means there's a 30% chance the taxi will go late. No matter which one you choose, overall, there's a 30% chance of being late. It says, find the probability that the taxi will come from garage C, given that it is late. So this was the probability of L, all right? This was the probability of L. Now what they're asking for right now is the probability of, it says a taxi will come from garage C given that it is late. So they want the probability of C given L. Now the probability of C given L, now this is conditional probability, is the probability of C intersect L divided by the probability of L. So what that means is the probability of we choosing taxi C and it come late. The probability of choosing taxi C and it come late will be probability of choosing taxi C is 0.2 times the probability of it being late, which is also 0.2, and then we divide it by the probability of the taxi being late. Probability of the taxi being late was 0.3. So work that out. 0.2 times 0.2 divided by 0.3, and that works out to be 0.133. 0.13. Nice and easy, soft. And that's a chance of we choosing taxi C given that it's going to be late. This takes care of question 7. So this is question 7, the statistics question. Very easy. And so now, of course, it's time to go to kinematics. All right, so as we go to kinematics, which means motion in a straight line, let's look at what question 8 is saying. Question 8, it says, a car starting from rest at A moves along a straight line, reaching a velocity of 24 meters per second, and it has a constant acceleration of 6 meters per second, blah, blah, blah. The car maintains this constant speed for 5 seconds, and then it is brought to rest again. It says, using the graph sheet provided, draw a velocity time graph to illustrate the information about the car. So now, using the graph sheet, this is the graph paper that they provide. And it says, using this graph to show the information that they're talking about. So first it tells me that what? It says the car start from point A. So I'm going to just put on the point A. Moves along a straight line to reach a velocity of 24 meters per second, traveling at a constant acceleration of 6 meters per second. So what that means, remember guys, first and foremost, acceleration is speed divided by time. So acceleration is the velocity of 24 being divided by the time. All right, and acceleration is 6 divided by the time t, and acceleration is 6, and so the time t must be 4 seconds, so t must be 4, t equal 4. If t equal 4, that means that when the time is 4, this is when the velocity is 24. All right, then it says the car maintains this constant velocity for 5 seconds. So for 5 seconds, that means it goes straight to 9 seconds. Then what happened next? It says it is then brought back to rest by a constant acceleration of -3 meters per second square. So the car decelerate then. So the car decelerating, so -3 is equal to, let's find out the time that it takes. -3 is going to be equal to, the speed is now -24 over a time t, all right? So t must be 8. T has to be 8. All right, so it takes 8 seconds to decelerate. So that means it goes back to rest 8 seconds. So 9 plus 8 is 17. 9 plus 8 is 17, yes. So those are the points, all right? So now just to draw the lines connecting them now, it starts from rest to here, and then goes from here to here, and then goes from here to here. All right. Goes from point A, this is point A. Then go back to rest. Now here's what the question says. Using the graph, draw the velocity time graph, this is it. Then it says determine the total distance traveled. So now, well, let's work, not like to work it here, but let's just do it here since we're already on this screen. Total distance traveled is area under the graph, which is area of this trapezium. And the area of the trapezium right here, the area of the trapezium would be equal to a half a plus b times h. Half the sum of their parallel sides, so it's a half of 3 Wait, this is 4. Let me say this is 4. So from 4 to 9 is 5. So it's a half of 5 plus. This distance here is 17. So half of 5 plus 17 times the perpendicular height, and the height is 24. All right, so the area of the trapezium gives us the total distance. So what are we saying? The area of the trapezium is going to be 5 plus 17 times a half times 24, that's 264 meters. All right, so 264 meters. That's the area of this trapezium. Nice and easy. So if the area of the trapezium is 264 meters, we can write it down around here that the area is 264. So the total distance traveled is equal to area under the graph, and the area under the graph, as we saw, it is equal to 264 meters. Nice and easy. The next part of the question says a second car moving at a constant velocity at 32 meters per second drives past point A 3 seconds later. It says a second car moving at a constant velocity of 32 meters per second. So it's driving at 32 meters per second. It drives past A 3 seconds after the first car left point A. All right, so that means it is, think of it as starting 3 seconds behind. It says calculate the length of time after the first car started that this second car meets it. So this car starts 3 seconds behind A, but it's traveling at a constant speed. All right, so just to give us some perspective, all right, this is car A. I know it's a box, but think of it as car A. So car A is traveling and traveling and traveling. It's traveling to some point right here. All right, and in total, it's going to this point, and it takes 17 seconds in total to get there. All right, you have a car that starts somewhere here. All right, think of this as the first. I shouldn't really call the first car A, you know. This is the point A, but the first car is car 1. This is car 2. Car 2 is all the way out here, and it's driving. They're going to intersect at some point. We just don't know the point at which they're going to intersect yet. All right, but what do we know about this car? We know that the second car is traveling at a speed of what? The second car is traveling at a speed of 32 meters per second. All right, and so as I was saying, so this is the second vehicle and this is the first one. Now, as we were saying, they are going to intersect when their distance are the same. So whenever their distance are the same, they are going to intersect. And I like to always have a schematic of what is happening. It makes it easier for me. So let's imagine the point B. B starts 3 seconds later. So let's say this is 3, right? This is 3. So B starts at 3 when the velocity is 32. So this is 28, this is 32. This is 28, 32. This would be 32. All right. And so this is B. All right. This is when B just starting and it's traveling with a constant velocity at 32. And then say intersect when A is in a constant velocity. So it can intersect anywhere between here and here. So let's say they intersect here. I'm just going to stop it here. I don't know if that's where A is. I don't know. I'm just assuming. All right. I'm just assuming. This helps me to do it. Now, when I do this now, to find out where the two car meets or at what time they are going to meet, they are going to meet when they're going to meet when the two cars have covered the same amount of distance. All right, and so in order to find the area of this dotted line in black, that will give me the distance, all right? And so I'm going to call this point T. I don't know what that is, but this is what I'm trying to find, T. Now distance, so the area of B is length times width, all right? So the area of car 2 is length times width. The length is of course 32. The length is 32. And the width is going to be T minus 3. So the width is T minus 3. So the length times the width give me the area, and that will give me the total distance that the car would have covered in that amount of time. All right, so let's write that down. So writing that down, we have the area covered by the second car by 2 is going to be length times width, which is 32. It's 32 multiplied by T minus 3. Now let's look at the area covered by 1 now, car 1. The area covered by car 1 is going to be Now the area covered by car 1, look how we're going to find the area covered by car 1. The area covered by car 1 is going to be the area of this triangle plus the area of this square, or some people just say the area of the trapezium. So the area of the trapezium, all right? Area of the trapezium. Area of trapezium is a half A. So this is the new trapezium now. So it's a half A. This green distance is A. This green distance is B times the perpendicular height. A is going to be from T to 3 is T minus 3. So this distance is T minus. Well, here to here is actually T minus 4. This distance is actually T minus 4. So that's going to be A. Then this distance is just T. All right. This distance is just T. And the height is 24. All right. And so the distance covered by car 1 at when they intersect is going to be a half. I'm going to write 0.5 for a half. A plus B, A is T minus 4 plus B, which is plus T, times the perpendicular height of 24. So the two cars, their distance are equal when, of course, this one is equal to this one. So when the area covered by car 2 is equal to the area covered by car 1, that's when they're going to intersect. So we need to equate when the area covered by car 1 is equal to the area covered by car 2. All right, so they're going to be equal when we say 32 times T minus 3, when that's going to be equal to a half of T minus 4 plus T. T minus 4 plus T, that's really 2T minus 4 times 24. So let's go ahead and simplify this now. This is when they are going to be equal. So let's continue and work this out. So 32T minus 96 is equal to, now 24 times a half is 12, and so it's 12 times 2T minus 4. Continuing, we have 32T minus 96 is equal to, this looks like 48 minus 48T minus 48. And then I can bring over the 32T over here and bring over the, let me see which one will be easier to bring over. Bringing over the 96, bringing over 12 times 2, my gosh, 12 times 2 is 24. My apologies there. So just to continue now, as you were saying, bring over the 24 over here. So we get T is equal to, bring over the 96 over here, we get 48. And so T is equal to 6. All right, T is equal to 6. And so the two meet 6 seconds after the second vehicle started. So they meet 6 seconds after the second vehicle started. All right, or some people might say they meet 9 seconds after the first vehicle started, depending on how you want to phrase it. Because remember, the first vehicle started 3 seconds before the second vehicle. So this is it. Nice and easy, soft. All right, nice. Now, let's do the next part of the question now. So the next part of the question says, a particle moves in a straight line with acceleration given by a is equal to 5t minus 1 at any time. When t is 2, the particle has a velocity of 4 and is 8 meters from a fixed point O. And it says determine the velocity when t is 4 and its displacement from when t is 3. So a particle is moving in a straight line and acceleration is given by 5t minus 1. Now, they told us acceleration is equal to 5t minus 1, right? Acceleration is 5t minus 1. Now, in order to get the velocity, remember that acceleration is the differential of the velocity, and so acceleration in reality is dv by dt. That's acceleration, all right? And so in order to get, so that implies that the velocity is going to be equal to the integral of the acceleration. So integrate it. So integrate 5t minus 1. So integrate 5t minus 1, and that will tell us that the velocity is 5t squared over 2 minus t, that's the velocity, plus some constant c. This is the formula that will give us the velocity. All right, but here's what they said now. They said at any time when t is 2, the particle has a velocity of 4. All right, so when t is 2, so when t is equal to 2, the velocity is 4. So when t is 2, we can plug 2 in here. And so what we're getting is 4 is equal to 2 squared is 4. 4 times 5 is 20. 20 over 2 is 10. Minus t is 2 plus c. So what does that mean? 10 minus 2 is 8. 10 minus 2 is 8. And we bring over that, and so we're getting c is negative 4. So if c is negative 4, the formula for velocity, so velocity in terms of time, we can call it v of t. The velocity in terms of time is equal to 5t squared over 2 minus t minus 4. So this is the formula for velocity, 5t squared minus t plus the constant velocity c, but c is minus 4. Let's put our minus 4 right here. Now here's what they really want now. They said find the velocity when t is 4. So this is this now. Find the velocity when t is 4. Now when t is equal to 4, we just need to find v of 4. That's going to be the velocity when t is 4. So v of 4 is going to be equal to, we substitute 4 here. 4 squared is 16. 16 times 5 is 80. 80 divided by 2 is 40. So we get 40 minus 4 minus 4. And so what we're getting is that the velocity is 32. So the velocity is 32 meters per second. That's the velocity when t is 4. What is the next part of the question? The next part of the question says find the displacement from O when t is 3. So find the displacement. Now displacement from the origin, displacement is the integral of the velocity. So we're going to integrate from 0 to 3 of the formula for velocity. So we're going to integrate 5t squared over 2 minus t minus 4, and we're integrating from 0 to 3, and that will give us the distance. So let's go ahead and integrate. So integrating, add 1 to the power, divide by the power, we're going to get 5t cubed over 3 times 2, which is 6, minus, integrate this, we get t squared over 2 minus 4t. And all we need to do is plug in the values of 0 and 3. So plug in the values of 0, or plug in the value of 3, and what are we getting? We plug in 3 right here, and we get 5 times 3 cubed, 5 times 3 cubed divided by 6. So we'll plug in 3 here, we get 5 times 3 cubed divided by 6 minus 3 square divided by 2 minus 4 times 3, and I'm getting 6. So I'm getting that the distance is 6 meters. Nice and easy, soft. All right, so this gives us the distance, 6 meters. There's no issue with this question right here, none whatsoever. And this concludes the paper, nice and easy, soft.